now that we've had our intro into the primitive variable types and we've seen what range of values they can take on, we'll now focus on some slightly more interesting and advanced variable types, and we'll start off with strings, which we're going to cover in this section. So we'll first focus on exactly what strings are, so what kind of values they can represent, and why they're not considered primitive variables like the ones we've seen so far. After that, we'll take a look at some common operations that we can perform on strings, as there's a lot more functionality involved. They're a lot more powerful than some of the primitive types. So, first of all, what exactly are strings? Well, we've actually seen examples of strings in, I think, the very first section. We just created a character name. So that's one use of the string type variable. Other uses include stuff like messages or text within your code, particularly when we're dealing with UI elements and we're dealing with text elements. Any kind of input or output is usually in a string form. So really good for representing messages, texts, names, anything like that. For example, going back to the video game character, we might create a name and store a string within that name. So let's have something like letName of type string equal something like mammoth interactive. Okay, so right off the bat, you might notice that it actually looks quite similar to a character type variable in the sense that it has the double quotations. So there's a couple of differences. The first is that we've explicitly told the compiler that we're dealing with a string, and the second is that we have many more than just one character in the string. And that's really what separates out a string from a character. A string is essentially a list or a collection of a bunch of characters all strung together, hence the name string. So this is why it's not considered one of the primitive type. It's because it's essentially a list or a collection of a bunch of primitive type variables. Now, while this makes it take up a lot more space in memory than a simple character, it also adds a lot of functionality and makes these strings a lot more powerful than the primitive types. So much like with character type variables, we can enter any combination of letters, numbers, or symbols in here, but unlike characters, we're not limited to a certain length, so we can actually have an empty string if we want. This is still a valid string, or we can have as many characters as we want within a string. As well, we can do things like add strings together. We can get substrings from within strings. We can return stuff like string lengths, and so on and so forth. So now let's take a look at some of the basic operations we can perform that have to do with strings, and then once we're comfortable with these basic operations, I'll show you some even more cool stuff we can do. So let's start with the very simple operations. Let's just go over here. And what we're going to do is just retrieve the count of this particular string, or the number of characters within it. Because strings are collections, we do this in exactly the same way as we would if we had like a list of numbers, for example. So we can say let count equal name dot, and then we just simply call dot, we're just going to say count. Okay, and actually you guys probably can't see that, so let's zoom out. So this is the one we want, and this basically gives the index distance from the very first character up until the last. Okay, so in this case it's 19, that sounds about right. There are 19 characters within this particular string. So there are operations that we can perform on simple variable types. Then this is how we do it. We just call the variable name and then dot whatever we want. Additionally, we can actually pass in a literal value here if we'd like, rather than a variable name. So if I were to replace name with this string name, okay, in this case we're going to get the number of characters within this string here, which should just be 4. So once the compiler finishes loading, we do see a 4 there. However, I actually did want the name non-string version. Now, if we wanted just the first or last characters, we could get them by index, or we could just simply call our name.first and name.last. So we could say let first character equals something like name.first, okay? And what this does is it will return a character. Now, you'll notice that, actually, let's pull that up again. So when we start typing in first, it doesn't just return a character, it returns an optional character. The reason it returns an optional character is if we have an empty string, so we saw something like an empty string that looks a little like this, okay, this is considered an empty string, then the first character is actually nil. Now, we haven't covered the concept of nil yet, we will in a couple of sections. For now, just recognize that if we're returning a character by guessing our string.first, it may or may not exist. In this particular case, it does indeed, and the very first character is just an M as we see here, specifically a capital M, because the capital and lowercase m's do have very slightly different values. Okay, similarly, we could get the last character, so last char equals name dot last. Okay, and again, same situation, we return an optional character. In this case, it is an E, as E is the last character there. Now, the last major operation I want to go over with regards to strings is going to be to retrieve substrings, because it's actually quite a tricky process if we're not familiar with it. That's not to say there aren't many more operations we can perform, and I do encourage you to check them out. Just, type in the name dot and it will give you a list of all of the possible operations you can perform. There's quite a lot, but I'm just going to focus on the substring section for now. So, getting a substring of a string in Swift relies on indexing variables, so it's unfortunately not quite as easy as with some other languages where you can just call a .substring function, you can enter in a start and end index and it will return the string. For this we have to create indexing type variables and use those. So let's say, for example, I wanted just the first word from the string. All I want is mammoth. That means I have the start index of 0 and end index of 2, 3, 4, 5, 6, 7. It will be 7 here. Okay. So there's a few ways I can go about doing this. I could say some string mammoth. I could specify it to be of type string, and I could set this equal to, let me just zoom in for you guys. I could set this equal to our name dot, and actually I'm going to have to zoom out so you guys can see all of the possible functions. We'll go substring, okay, and as you can see there's a few options. We have a substring from an index, so if we provide a beginning index, it will basically take everything from that index until the end of the string. This is the opposite of the to string.index, in which we'll provide an end index, so it takes everything from the beginning to the end. Alternatively, we can provide a range if we want kind of the middle of a string. So let's just go up until an index, just because we want the very first word here. So now notice that it takes in a string.index as an argument. This means that we can't actually pass in just a number like 7 and it's going to provide us mammoth. We have to actually retrieve an index type variable. So this is why getting substrings can be a little tricky, because we're not just entering integers, we are actually getting indexing type variables. So what we'll want to do is create an index variable. So actually I'm going to separate this out from the rest, just because this is kind of its own little section here. So what we're going to do is we're going to say index, let's call this end index for now. Okay, and this is going to be our, in this case mammoth is our, this is going to be our name string, so we should pass in name. Okay, and we're going to do name dot, we start typing in index, you'll notice that a lot of different options come up. Okay, so the one we want will take in the very first string index, and then it will take in an offset. So this is actually the one we want, should be the very first one. It says its arguments are string.index, and it's an offset by index distance. So let's select this one, make sure you have this function selected. So what this takes in is a start index here, and it takes in an offset by, so we can consider this kind of the end index. Well, for now, our start index is just going to be the very first index here, because we want the very first word. So we're just going to say this is our name dot start index. Okay, so that will retrieve this index right here. So now it's going to take everything from the right onwards. However, we want the final index to be this guy, so we want to offset by 1, 2, 3, 4, 5, 6, 7. So let's just enter in 7 under the string.index distance. So right now, don't worry about this error message, by the way, this is having to do with this because we haven't provided an argument yet. So now we have our index, okay, and it's basically this spot right here within the string, okay? It's this spot here. So we're actually going to take this and put it just above our mammoth constant. And now what we can do is actually just pass in the end index here, end index, and that should take care of it for us. Okay, and there's still an issue, that's because I haven't added the equal sign here. So now once the code is run, we should see that this says mammoth here, so we've successfully retrieved the part of the string that we want. Similarly, if we wanted the second half, which is just going to be the word interactive, what we would do is we would get a new index, which should be offset by 8, I believe. So if we said something like let start index equal our name, let's do an equals name.index, okay, and it's going to be the first one that we want. We just want the name.start index offset by, and in this case it's going to be 8 because we're starting right here where this I begins. Okay, and then instead of having a substring to the end index, we're actually going to have a substring from index. So then we could say let interactive of type string. Again, the type not strictly necessary, but good practice. We're going to say name dot substring. Okay, and now we want substring from a start index basically. So it would be a little more helpful if we had slightly better labeling, but that's just something that we have to put up with. So in this case, we want it from the start index, and this should return our substring interactive. Okay, so once it finishes running, then we do see interactive popping up here. So now we've successfully retrieved the correct string. Now, retrieving strings from the middle, substrings from the middle, is a little trickier. In this case, what we can do is we can get a start index, an end index, and then we can provide a range. Okay, so now this time maybe I want the word moth. Okay, so this is going to be my start index of 0, 1, 2, and 3. It's going to be start index of 3, and end index of 7. So I'm actually just going to copy some of this code here. I'm going to take this. Okay, let's copy it, and we're just going to paste it down here. I'm going to call this end index 2. Okay. And I'm going to create another start index. Let's copy this, paste it down here. It's going to be start index 2. Okay, now the offset, the very first start index, is just going to be 3 because we want it from this particular location. It's going to be offset by 3. And then we want up until 7, okay, because we want to end it right here. Now for this case, rather than doing name.substring from or name.substring to, we're just going to say let moth or something of type string. We're going to set this equal to name.substring with, and then we're going to provide a range. Now we haven't really talked too much about ranges. I'm just going to show you how to just specify our range. We'll actually do a whole section on just ranges a little later on. Just for now, bear with me here. So now we're going to provide our start index 2. Okay, so that's our very first start index. Then we're going to do a dot dot and then another dot. Then we'll do end index 2 as well. Okay. And actually what this will do is this will include one extra number, so we want the dot dot less than. Oh, and I see the issue. We have got the names mixed around, so let's just take this, copy this, and paste, and then this will be our end index. So again, important to make sure you're naming your variables correctly so that we don't get issues like this. So once the code finishes running, we do see that we get the string that we want, and this is called moth. So now we've successfully extracted a substring from the middle of our original string. Now as you can see, this actually took a little more work than in some other languages. I know with Java we can just say our string.substring, provide a start index and end index just as integers, and that takes care of the work for us. Unfortunately, it's a little more complicated in Swift, but then again, there's a lot more functionality involved with strings in Swift than with strings in other languages. Okay, so those are just a few of the basic operations. Like I said, there are many, many more operations we can do. We can do stuff like capitalize specific letters, we can retrieve characters at certain indexes, and so on and so forth. I won't go over all of the common operations. It's important to kind of discover some of these for yourself, but Playground's a great way to test all of those out. There's just two more points I wanted to cover. The first being multi-line strings. So this is actually an addition to Swift 4 over the other Swift iterations. And then we're going to go over string interpolation. So if we wanted multi-line strings, we use a triple quotation mark operator. So I could create a string called, I don't know, multi-line string or something. And we're just going to say this of type string. I'm going to set this equal to some kind of a multi-line string. Okay. So now we can put whatever we want in here. We can say hello, how are you? And then something like, I'm doing very well. How are you? And so on and so forth. We could have a whole conversation in here if we want, using correct grammar, of course. Okay, and so on and so forth. So this is how you do multi-line strings. Again, this is the syntax is new to Swift 4, and actually I think is very useful. Okay, similar to single-line strings, there's really no limit as to how long these strings can be, but do try and be reasonable about the length of your text. Okay, so the final topic that I wanted to cover with regards to strings, and actually there's kind of one more, but I think I'll save that for the operators section. That's going to be sticking strings together. It's actually quite easy, but yeah, I'll save that for the actual operators part of our variables subject tutorial. And so this last topic, string interpolation, is very, very useful, because then this prevents, or rather allows us to create strings and insert other variable values within those strings without having to explicitly convert them to strings. So let's say I have a number of eggs. First thing that comes to mind, a dozen eggs. So we have this variable, or in this case it's going to be a constant, and it's going to be called number of eggs. Okay, it's going to be a type int, and we'll set it equal to 12. So we have a dozen eggs right here. Well, now let's say we wanted to have a string that contains this variable in it, and it can say something like, we'll call this something like eggs string of type string. Okay, and actually let me zoom in for you guys here. So this string is just going to be basically equal to I have, and then we want some number of eggs. Okay, so right here, rather than writing 12, we want to insert the variable value here because we don't necessarily know how many eggs we have. So what we can do is use this string interpolation where we start with a backslash, we open up the brackets, and then we put some kind of a variable value within here. In this case, it's just going to be number, and let me zoom back out, number of eggs. Okay, so this is our integer we just created. Okay, so now what this is saying is basically we start off with this string, then we're inserting this value, number of eggs, we're converting that to a string, or rather letting the compiler do that, and then inserting it here. So now as you can see, it says I have 12 eggs, or I guess you would if it didn't fully cut off. Okay, so we can insert any kind of variable value within here, provided its output is some kind of a literal, such as a number. And this is really handy because this, if we weren't allowed to use string interpolation, what we'd have to do is say I have, that would be one string, and then we'd have to convert number of eggs to a string, add that into this, and then add this third string, which is going to be eggs, onto the end. So this just saves a lot of time and hassle. Alright, so I think that's all I'm going to go over as far as a basic intro to strings go. Like I said, there's a ton of different operations we can perform on strings. There's really a lot we can do with them. They're a very powerful data type, and again are used to represent text or messages. So I do encourage you, especially because the playground is so easy to use, to test out some of those other operations you can perform, get to know them, and see how much fun you can have with them. Otherwise, I think our next topic is going to be the topic of optionals. So in that we'll start talking about nil values, how to detect whether a variable has a value of nil or some kind of a literal value, and what we can do with these nil and optional variables.